Hello everyone, this is Zahid Bashir. I am a faculty member in Department of Commerce, University of Gujarat, and PhD research scholar in Delhi College of Commerce, University of Punjab. Yesterday we have discussed the condition where T was greater than 25 and N was greater than 25, and we have found the cross-sectional dependence in our panel. Then we checked the second generation unit root testing, and we have applied the common correlation effect on a condition that dependent variable is stationary at level and independent variable is also stationary at level. And we have also used a number of variable with mixed stationarity, while we consider that dependent variable is stationary at first difference and independent variable are stationary at mixed level. And we have used dynamic common correlation effect there. So this part is clear in the last video. Now let's suppose if cross-sectional dependence is not found, what we need to do if cross-sectional dependence is not found. If you found cross-sectional dependence, then you need to apply this rule. But if you do not found cross-sectional dependence, then you need to apply this rule. If you understand that this route does not require that cross-sectional dependence should not be here, in that case, you need to apply first generation panel unit root test like IPS and Lin-Levin. And if your dependent variable and independent variable both are stationary at level, then you need to apply pooled OLS, fixed effect, random effect, or seemingly unrelated regression. This is the first criteria. But if you found that your independent variable are stationary at mix, then you are going to use the panel ARDL. So today I will elaborate this procedure with the help of one of the data set that we have here relevant to high income countries. I would like to share with my participants regarding this data so that you may be able to use this data set for your consideration. Let me share with both participants about this data set. This data set is readily open in your Stata. So you just need to open it as a dataset file in Stata. You don't need to copy and paste. You just need to open it in your Stata. So in order to open this .dta file in Stata, you just need to open your Stata software. For example, I go to my relevant bar and I open the Stata right from here. When you open the Stata, you just need to go to the file, go to open, and go to the folder where your data set is basically existing. So you need to open this data set. If you find out here, the data set is basically provided. This is the same set of data set that we have previously used, but with high income countries. So what we need to do now, we need to check the cross-sectional dependency, but always remember that whenever you load a data set in Stata, first of all, you need to check or you need to declare your data set to be panel. So the first procedure is xt set. Then you need to click on IDs and years. So click enter, and now your data set is declared as panel. The second thing that you need to do here is basically to run your panel static model commands like fixed effect, random effect, and pooled OLS, and let the Haussmann test decide between fixed and random effect, and LM test between random and pooled OLS. So let us check which is the estimation method which we are going to use. XT rect. You need to put here dependent variable, then you need to put independent variable one by one like this. You just need to click on these independent variable. The last one. So before you run this command, kindly drop the selected variable like fixed effect estimation and random effect estimation. You need to drop it from this data set. Now you can run the fixed effect. After running the fixed effect, if you see here the result, the overall R square is approximately 13%. Your model is fit, and there are some variables which are significant at 5%, significant at 1%. There are some variables which are not significant, like CF is not significant, while SEG is significant, GDP growth rate is not significant, GDP per capita income is not significant, TROP is significant, inflation rate is not significant, exchange rate is significant, real growth rate is not significant here. If you see the F test is significant. It means there is a fixed effect in your panel regression, or as per due to your cross sections or due to your time dimensions, there is a possible fixed effect here. So we need to save these results using estimate, store, fix. Now we need to run the random effect command here in the same way. RE and store this result to estimate, store, random. Now we need to run Houseman fix random. If you see the p-value here, it is less than 5%. It means we are going to finalize the fixed effect model here. Now, when we finalize some model, whether it is fixed effect or random effect, always use robust command to finalize the command, to finalize the results. So after fixed effect, you need to put VCE robust. Now it will finalize the command. After you have finalized the command for your regression estimate, the next step that you need to do here is to apply the cross-sectional dependence test. So we are going to apply the cross-sectional dependence test in the same way that we have done previously. This is the cross-sectional dependence test. And the steps involve that you need to apply the regression first, and then you need to run this command for checking the cross-sectional dependence. So we run this command, and we need to see the Passerand test PR value. If this PR value is greater than 5%, it means your data does not have cross-sectional dependence if it is greater than 5%. But if it is less than 5%, it means there is a cross-sectional dependence. So if we see the guidelines, if PR value, all right, there was an interruption from the Wi-Fi connection. I was telling that we need to understand this guideline criteria. If PR value is less than 5%, it means there is a cross-sectional dependence. And if the PR value is greater than 5%, it means there is no cross-sectional dependence. So in our case, if we see the PR value, it is greater than 5% now. So when the PR value is greater than 5%, it means there is no cross-sectional dependence. In that case, we need to move on this direction like this. But if you found the cross-sectional dependence, then you need to move the other direction that we have already tested in yesterday's session. So today we are going to confirm that when there is no cross-sectional dependence, then what we need to do? We need to conduct first generation panel unit root test like IPS and LIN 11. So what that again and again, I need to share the screen again. Let me share the screen. All right. So I was discussing that you need to understand the next procedure. Next, we need to test the first generation unit root testing. So in order to apply this criteria. So we have run this command. Our first condition is fulfilled. Our second condition is fulfilled because TR value is greater than 5%. So there is no cross-sectional dependence. So if we find no cross-sectional dependence, then we need to apply the first generation unit root test like LLC and IPS. Now in Stata, we have the built-in commands for Stata here. We just need to go to our statistics, and if you see here, there is an option of longitudinal and panel. And if you see here, there is also an option of unit root test, which is panel unit root test. This is a built-in command which basically includes the first generation panel unit root. So we don't need to install the commands for first generation panel unit root because they are already included in our system, in our software. While if we need to run the second generation like CADF or CIPS, then we need to install them first. So you just need to go here and you will find here the IPS unit root and the 11 lin chew. IPS, this is the IPS unit root, and this is 11 lin chew. So you just need to click on IPS, include time trend, and you need to tell them for which variable you are going to check the FTI. If you see here, there are three dots which provides additional option whether you are going to take this variable at level or whether you are going to take this variable at first difference or at lag. So if you click on these three options, by default, it consider no lags. You can decide whether you are considering lags or whether you are considering the difference. So I am considering here no lag, no difference because I am taking this variable at level. So you just need to click on OK and it will run the command. So this is the basic command for your test, which is IPS unit root test for FDI. So how can we decide whether our variable is stationary or not? First of all, you need to see this p-value. If this p-value is less than 5%, it means your variable is stationary. The second thing that you need to see is the t bar value. It is the coefficient value of your variable that you need to show into your table. So this value is minus 3.5084 and it is highly significant. And the second thing, you can also compare this value with these levels. At 1% level, it is greater. At 5% level, it is greater. At 10% level, it is also greater. So this value is greater from these critical values at all levels. So what we need to do, if you remember the procedure, we have considered uh, an output tables like this. We can put it here for our consideration. We can create this table again. For example, this one was the table. I need to use unhighlighted text here. and I need to replace here the values, and I need to write here IPS, and the second one is Levin Lynch. The name of the test from here, LLC and IPS. So I just need to write here LLC. I can include here another column. I can write here at first difference. I can rectify this table using the options I have. Layout, eraser, and this one. All right. Now this table is okay, and I can arrange this table in more better way. Like I can, yes, this one. So now it is ready for first generation panel unit 2 testing. First of all, I have applied the IPS test at level because I have not created here the first difference. So you need to take the value of T bar from here, and this is greater than 1% value, this is greater than 5% value, this is greater than 10% value, and it is highly significant. So what you need to do, you need to place this value at level, and you need to include 3 steric signs here. Now you need to consider the same value using first difference. So how can we create the first difference? As I have told you yesterday, that you need to include D dot before the variable name. So before FDI, you need to include here D dot. Do not create any kind of space between these words. You need to include D dot along with FDI. So this is the first difference command. So you just need to run this command, and you will find the value of your variable at first difference. It is also highly significant, and it is greater than the critical values. So you need to place this value into the table, and like this, and include three-steric. It means this variable is basically stationary at a level as well as at first difference. Now your dependent variable is stationary at level as well as at first difference. If we see the condition for our criteria, our initial criteria, if your dependent variable is stationary at level, let me check the independent variable too. If they are also stationary at level, then we are going to use fixed effect, random effect, or pooled OLS for our estimation. But if you found the independent variable with mixed level, then we are going to use panel ARDL for our estimation, which is a new thing for you as a participant. Pooled OLS, fixed effect, and random effect we have already done in this session, where we have used T less than 25 and N less than 25. We have analyzed the fixed effect, random effect, and pooled OLS command. And if still your dependent variable and independent variable shows stationary at level, then we are going to use the same command that we have used previously. But if your independent variables are showing stationarity at mixed level, then we are going to use panel ARDL. So let me show you the procedure for all of your variables. So you just need to put here your command again. What was the command? This is the basic command that you can use with all of your variable for level. After FDI, we are going to use FD with trend. And if you see the p value, it is less than 5%. And if you compare this value with the Z statistic, this Z statistic is less than this value, less than this value, and less than this value too. So we could not consider it as a you can say we cannot consider it a significant value as per this test, because it is less than all three levels. So this variable is not stationary. This variable is not stationary at any level, because this value is less than the other levels. So what we need to do, we need to create its first difference. So again, consider this value and include v dot here, and you will find the value. Now this value is greater than these three levels. Therefore, it is stationary at level. So you need to put this value into your table at first difference like this, and you need to add these tariffs. So it means we are going to have the second scenario, which is basically the panel ARDL model here. Uh, Again, we need to check some of other variables too. So in order to confirm the mix stationarity, like we can use the same command here, the same command for trend. So we need to replace the variable with the next one like this. So you can see this value. This value is less than at 1%, but it is greater than at 5% and 10%. So we can say we can apply the 2 star here. So you just need to copy this value. You need to place here, and you need to apply 2 star, because it is significant at 5% and 10%, but it is not significant at 1%. But if it is also significant or greater than 1%, then we can place 3 stars here. So we can, this is still stationary according to this criteria. This is still stationary here. So we can check its first difference. We need to place here d dot before the variables, and we can put here their value. This value is greater than the other three levels. So we can take this value and we can place this value here with 3 stars. I think there is a question from the participant. If sir at percent, then 1 star. If yes, if it is at 10%, if it is greater than 10%, then you need to place only 1 star. For example, if you see the previous one, it was greater than only 5% and 10%. Therefore, I use 2 stars. But if it is only greater than 10% and less than the 5% and 1%, then you are going to use the 1 star only. That means it is still stationary, but that means it is weakly stationary, weak stationary, basically. The 5% is the basic criteria, while the 10% is basically the weak criteria. So you need to include only 1 star in that case. All right. So so we have found another one. In the same way, in the same pattern, you need to find out the first difference of the all other criteria. So the initial estimate indicates it's a mixed stationarity, because one of our variable has so far indicated mixed stationarity here. So you need to find out the stationarity of the other variable in the same way. So let's suppose our initial criteria is met, and we have find out that our independent variable are stationary at mix, because we know this procedure, pooled OLS, fixed and random. We need to understand the panel ARDL procedure, because one of our independent variable has already shown that it is not stationary at level. So we consider this criteria. So now how to apply the panel ARDL? You need to understand some basic consideration regarding the panel unit root. And I will let you know the whole procedure tomorrow. But today you need to understand some basic consideration regarding panel ARDL, that what is panel ARDL and why it is applied. I have a research paper for your consideration, so that you may understand some basic things regarding panel ARDL approach. So this is a research paper on fertility and female labor force participation in Asian countries. And this paper basically applied the panel ARDL approach. So you need to understand how this panel ARDL is applied. And you need to understand that this approach is basically the ARDL method with three sub method or three sub approach. The first one is DFE, the second one is PMG, and the third one is MG. If you see in this framework, you also found their name, panel ARDL with PMG, MG, and DFE. These are the estimation method. While the pooled OLS, fixed effect, and random effect, they are static panel method. They are static panel method. While in ARDL, you are going to run PMG, MG, and DFE. So, what are these and how we basically study these, and what are the other things that you need to apply here? Always remember, when there is a feasibility to apply the panel ARDL, you need to understand some of the consideration here. The first thing is that you are going to run the Granger causality test. It is basically the assumption that data is known causal. So we need to run this command for our estimation, and I will let you know how this command is run for our procedure. Then we need to run the panel ARDL procedure, and we have three estimation method, PMG, MG, and DFE. And we need to run the Hausman test in the same way that we run with fixed effect and random effect, in order to decide whether we are going to finalize the PMG, MG, or DFE, which model is preferred according to panel ARDL. So we need to run the Hausman test here. So the ARDL method will give you the short run as well as the long run estimates. It is not the same regression analysis that you run with simple regression. It is basically divided into two segments. So whenever you run the panel ARDL, it is divided into two sections. One is called the short run estimates, and one is called the long run estimate. So whether you are going to run the DFE, the PMG, or MG, you are dealing with the short run as well as with the long run estimate. So we will consider this using the panel estimates. So I will let you know more about this procedure, because before applying this procedure, you need to understand the panel ARDL first. So this is basically the methodology they have applied. They use the data for this study from World Bank, like WDI. They have used the time duration from 1919 to 2018. And they have a number of countries here. Let me check how many countries they have used. These are the countries they have taken for their analysis. And I believe they have mentioned in their abstract here that how many countries they have used 39 Asian countries using the panel 1990 to 2018. So if you see, they have met the criteria of n greater than 25, while the T criteria is about, if you can see here, 18 and 10, 18 and 10, 28, 29 years. Approximately, this is 29 years. So both of these criterias are greater than n 25. If you see this, this is meeting the criteria. T is greater than 25 and n is greater than 25. So they have met this criteria. The next thing is that we need to confirm from this paper. This is a very good paper, and it is written in the same way that we are going to apply the procedure. Next, how they have decided that they are going to use the panel ARDL. Uh, the first thing that the step-by-step procedure provides is that we need to check the cross-sectional dependence. Maybe they have mentioned it in somewhere, but they have mentioned that they have used panel ARDL. So always remember that panel ARDL is used when there is no cross-sectional dependence in your panel. Maybe they have mentioned in somewhere, but I will find out. So how they have applied the panel ARDL? Before applying co-integration and causality test, the stationarity. The first thing they have checked is stationarity. They have applied, and they have applied Levin-Linchu LLC test and IM Pasran-Shin test, means IPS test. The IPS test we have applied here. The LLC test is also available as a first generation. If you go to the statistic and you go to the longitudinal panel and go to unit root test, you will find here the Levin-Linchu. So it is also included here, so you don't need to worry about. So both of the tests are available. So they have applied the LLC and IPS test, and they have applied another test which is PPT, but you don't need to use it because they are superior tests. Levin-Linchu and IPS tests are enough for our analysis. The next thing they have done along with stationarity, they have done the co-integration test. It is the test which is basically used to find out whether there is a long-term relationship in your model or not. So this test is used to check that all variable are co-integrated or they have some long-term effect. So what they have cleared here, the first thing they have checked the stationarity and then they have checked the co-integration. And what co-integration test they have used? They have used the cow test, KAO, the Pedroni, and the Westerland test. I will let you know step by step how these tests are applied using the Stata. So let us summarize the procedure first. So what we need to do, at first, we need to check the cross-sectional dependency, because it will confirm that we are going to apply the, if I write the short term CD test, if not found, then we need to apply the stationarity or unit root using LLC and IPS. After that, what is the next procedure? The next is co-integration test. Co-integration test. What what options they have provided. They have provided cow test, Pedroni, and Westerland test. Now, they have provided these tests for our analysis. And after that, they have used the panel ARDL, using PMG, MG, and DM. Now, this is the procedure they might have applied. I will share this paper with you so that you may be able to consider it. As the time for today's session is going to end, so I will elaborate the further procedure in our next session, which is going to held on Monday. So keep watching the channel and keep watching the detail of this video. So I will elaborate on Monday. So do you have any question, Waqar, regarding today's discussion?
No, sir, I have no question.
All right, all right. So let's meet on Monday for further analysis. So thank you very much for joining and stay blessed.